If one day you could upload every memory to a computer, would you dare to? Artificial memory. Can we back up our minds like a computer? Imagine this. You're lying on your deathbed, but your memories aren't dying with you. Instead, every moment you've ever lived, every face you've loved, every lie you've told, every sunset you've seen is saved on a hard drive. Downloadable, shareable, maybe even sellable. Science fiction? Not anymore. Welcome to the new frontier of neuroscience and technology. Artificial memory. The idea that human memories could one day be stored, transferred, edited, and even experienced by others. It's a bold vision, one that sounds like it came from Black Mirror or Inception, but it's already in motion in real labs, with real scientists. Part 1. The brain is not magic. It's code. Memory might feel like something sacred or spiritual, but at its core, it's a biological computation. Your brain holds around 86 billion neurons, each capable of forming thousands of synapses. When you form a memory like learning to ride a bike or the taste of your grandma's soup, what's really happening is this: neurons are firing, electrochemical signals are transmitting, and new proteins are created to reinforce specific neural pathways. This is called synaptic plasticity, and one key mechanism is long-term potentiation. Long-term potentiation strengthens the connection between neurons that fire together, turning fleeting experiences into long-term memories. Think of it as writing a file to disk. But here's the catch: memories are distributed. A single memory might involve the visual cortex, the hippocampus, the amygdala, the auditory system, even your motor cortex. There is no single memory bank in the brain. Your identity is scattered across thousands of circuits. To extract or replicate a memory, we'd have to record and recreate an entire pattern of brain-wide activity down to the millisecond. Not just the neurons, but also the glial cells, neurotransmitter concentrations, ion channels, and even epigenetic states. That's a monstrous task. Part 2. Science fiction becomes science experiment. Despite the complexity, scientists are getting shockingly close. In 2013, researchers at MIT implanted a false memory into a mouse. They used optogenetics, a method where light activates genetically modified neurons to make the mouse remember being shocked in a cage it had never entered. It was one of the first demonstrations that memory is not sacred. It can be hacked. In 2023, scientists at the University of California created an AI that decoded speech from brain signals by interpreting the electrical activity of the motor cortex. This isn't just reading thoughts, it's a translator between neurons and language. Meanwhile, projects like Neuralink are developing ultra-thin brain implants that can read thousands of signals in real time. Their goal? Restore motor function. Sure, but long-term, it's about reading and writing the brain. The US military is also invested. DARPA's Restoring Active Memory program has funded implants that boost memory in brain-injured soldiers, achieving up to 35% improvement in recall. We're not just talking about saving memories, we're enhancing them. Part 3. WHO owns your memories? Now, pause for a second. If we can read memories, what's to stop us from stealing them? Could governments subpoena your brain in a court of law? Could advertisers implant product memories? Could black markets emerge for emotional experiences, selling first kisses, childhood Christmases, or even trauma? Science is already dancing with this line. In 2021, researchers at Kyoto University created an AI that reconstructed images from brain scans, visualizing what someone was seeing with no cameras involved. The images were blurry, dreamlike, but unmistakably accurate. This raises chilling possibilities. What if you no longer needed consent to see inside someone's mind? Worse, what if you could alter it? There's already progress in memory erasure. Using propranolol, a beta blocker, some psychologists can weaken traumatic memories in PTSD patients. It's real-life eternal sunshine of the spotless mind. But here's the ethical riddle. If you erase pain, do you erase the person? Part 4. The race for digital immortality. Beyond all this lies the most radical vision of all: whole brain emulation. If we can map every synapse, every neuron, and every biochemical reaction in a brain and simulate it digitally, then we could, in theory, create a conscious digital version of a person, a mind that can live without a body. Immortality via upload. This isn't just theory. The Blue Brain Project in Switzerland has already simulated 1 million neurons. The Human Brain Project is attempting to model the entire neocortex. And Elon Musk? He once suggested that, with enough bandwidth, we could merge with AI. But the real breakthrough may come from quantum computing. Unlike classical computers, quantum systems can simulate the brain's fuzzy, probabilistic nature, potentially giving us a system that can think in a human way. Part 5. The final question. Should we? Even if we can back up the human brain, a haunting question remains. Should we? Will we trust corporations with our inner lives? Will memory become a commodity? Will we forget how to forget? In some traditions, memories are sacred. In others, they're seen as illusions. Buddhism teaches us that clinging to memory causes suffering. Stoics remind us that every moment is fleeting. Maybe it's the impermanence of memory that makes life beautiful. But now, we face a future where nothing is forgotten, where your mind is searchable, where identity is editable. So what makes you you? Your biology? Your stories? Or your data? That's the next revolution. Not in AI, not in quantum computing, but in the philosophy of self. Triggered by the science of memory, we're no longer just decoding the brain. We're rewriting what it means to be human.